Okay, awesome. Our recording is up and running, guys. And just again, welcome to today's session. And in today's session, we're going to be covering present value annuities. But today is part two because there is part one already, which we did where we're introducing these annuities and other things. So today, this will be part two, and it will be the last part of financial mathematics. So let's quickly go and have a look at what we need to cover today. Essentially, it's questions, about two of them. So our session is going to be a bit short. But essentially, last time, just a quick brief, I introduced you to present value annuities, and I said there's key terms that you should look for when dealing with present value annuities. One of the terms is loan, the other one is borrow, bond, mortgage, or mortgage, others call it deposits, and so on. And remember, we said present value annuities are associated with debt, borrowing money. Okay, while future value annuities, which we covered on a separate lesson, are associated with savings, investments, and so on, retirement, and their friends. So the formula for present value annuities is as given here. So please do not, misunderstand or, write the right answer, but you are using the wrong formula. For example, the future value formula. And then I defined X would be the installments that we put in, PV would be the amount which we owe the bank, and I would be the interest rate. Also, in some problems, they will call it the lending rate because we're borrowing money. And then, guys, if you remember, we did a couple of problems where here we're looking at Lirato, who's paying off a loan. And we did all the calculations here. They were asking how many monthly payments will it take for them to repay the loan. So we did the calculations here. We saw that it will take us around about 58 months. And then we did question 2, guys, of Temba and the story. You can go and review that lesson. Did another question here, and so on and so on. But maybe to zoom in here, what I need you to understand for financial maths is being able to use the timeline to be able to solve your problems. Guys, very important. So I advise that if you are struggling with timelines and thinking around timelines, you definitely need to review the lesson, the last one, part one of present value annuities. Thinking around the timeline and drawing it and making deductions is very important. So please go and watch that again. And we did other calculations here, which I'm not going to go into. There was so much which we did, guys. But I gave you homework. Did any of you do your homework from the last lesson? Do we have anyone who did their homework here? If you did your homework, give me a thumbs up. And if you didn't do your homework, please give me a thumbs down. Let me see. So it looks like you guys didn't do your homework. There's an important quote that I'm going to write for you, which is as follows. And this, just please remember it as you even go to your final exams. So this is the quote I want you to keep in your mind, which is that mathematics is not anyone wants to complete this. I'm sure you've heard this from your teachers. Mathematics is not a what? It is not a what, guys? You haven't heard it from your teacher. Okay, I'll give it to you. It is not a spectator sport. What does that mean, guys? Tembisile, what does this quote mean? What does it mean? Kamokelo, what is your understanding of this quote here before we start this problem? It's very important given that you guys didn't do your homework. What is your understanding of this quote? Lebogang. Ayabonga, what is your understanding of this quote?
I think it means that in order to master maths, you need to actually do it and not watch someone doing it. Because watching someone doing it is not the same as you actually doing it.
On point. So you guys come in a session, you observe, you understand the concepts, and I give you homework problems. Those homework problems are meant to ensure that you are not a spectator. So you see how you watch soccer and figure out what is happening. With mathematics, you can watch it, be convinced that you understand what is being said. But when you come to the question, you realize that maybe my understanding is not on point. So, guys, in other words, please practice. Please practice. When you're given your homework, please go and do it. Okay. So let's jump to this question here, which is I need someone to read it for us. Any volunteer? You can jump in, guys. Let's take Tejo. Please read the question for us.
A loan of 250,000 is repaid over 5 years with equal monthly payments, starting 1 month after the loan was granted.
Okay, on point. Please read question 1.1 for us, and thank you.
Calculate the monthly repayments if the interest on the loan is 1% per annum compounded monthly.
Awesome. Thanks for that. So let us jump and see what is happening here, guys. So if we observe here, the first thing that we need to do, if you remember from our previous problems, I said in the exam, because things are clustered, when we are dealing with financial math, especially annuities, we need to look for the key terms. So what are the key terms, guys, from this here? Let's get them out soon.
Loan.
On point. If you look at one of the key terms, it is loan. What is the other one? When you read our question, they say repayments, meaning we are repaying something, you know. And someone else can see other terms here like monthly payments, which means it's an annuity. Maybe let's put that monthly payments. So we already have figured out that it is an annuity because the payments are coming in periodically. So we have monthly payments. And after looking at these terms, guys, what we should easily be able to conclude is that we are dealing with a present value problem. And because we are dealing with a present value problem, we should remember our very important formula PV, or present value. This will be X into, which is the monthly installments. It will be X into 1 minus 1 plus I, all to the power of minus N. And all of this is divided by I. So now, if you remember, guys, I usually pose questions. And the first one is, what are we looking for? They told us already there, but I'll pose it anyway. So what are we looking for? And if you observe carefully, from 1.1, what we can tell we are looking for is the X, which is the monthly payments. Do you guys agree? Right. So that is what we are looking for 1.1. We're trying to find x. So if you look at our equation, I can actually solve for x. Guys, if we quickly make x the subject of the formula, I'll show you how we do that. But other people usually prefer plugging in. So maybe let's plug in. It will reduce confusion. So remember, after figuring out what are we looking for, we ask ourselves, what do we have? So I need you guys to quickly give me what we have. What do you see that we have?
We have PV, which is 250,000. 250,000.
On point, we have the amount which we are trying to borrow, which is 250,000. So it will be PV. What else do we have?
Interest 1%.
On point. So we have I equaling 1%. What else do we have, guys?
We have the N, which is 5.
We have the N, which is 5. What else which is important that we need to include here?
M, which is 12.
And what is M for? Or what is M?
Compounding period.
You guys are geniuses. So M is the compounding period, guys. So you understand what is happening. So now what we need to solve for is X. So what we are going to do is to go and substitute. So we'll have 250,000. That's 25. Right, that we'll have 250,000 equals X into 1 minus 1 plus. So our interest, guys, we were told it's 1%, isn't it? Divided by, since our compounding period is monthly, we'll divide that by 12. And then this will be, if you look carefully, it will be minus 12 multiplied by 5. There. So we'll have minus 12 times 5 there on the exponent part. And all of this should be divided by our interest rate divided by the compounding period. So essentially, it must be divided by 1% over 12. And remember that all what we are doing here, essentially, we are trying to solve for X. So if you look carefully, I'm going to take the 250,000 multiply by what is at the bottom there. So remember that when you are trying to solve, when you are trying to remove the denominator to the other side, like this, when I want to move this to the other side, I multiply by it. Okay. So that means I'll have what? 1% divided by 12. And I'll have X multiplied by, guys, can you please punch in on your calculator what is going to multiply X? So punch in that 1 minus open bracket 1 plus 1% divided by 12 all to the power of negative 12 times 5. What do we get? Anyone who has their calculator nearby? You can punch in and give it to us. You guys should make sure that you always have your calculators, okay? So if you have it already, you can give it to me. And if I finish before you guys, it means you are not participating here.
It's 0, comma.
You're getting what?
0, comma 0, 4, 8, 7, 5, 0, 7, 6, 9, 0, 2.
Okay, let's make it maybe to be 4 or maybe 5 decimal places. So you should be getting 0, looking at my calculator here, 0.04875. Are you getting the same thing?
Yes.
Awesome. Thanks for that. And now I need you to quickly multiply this left-hand side for me. So what do you get? When you multiply that 250 by 1% divided by 12.
625 divided by 3.
625 divided by 3, and we have this x multiplied by 0.04875. So we know that we are looking for x, not x multiplied by something. So what we should do is to go ahead and quickly divide. So what we should do is to divide by 0.04875. And what we do on the left-hand side, guys, we also do on the right-hand side. So on the left, on the right, it's going to cancel. And I need someone to give me what x will be. So when you say 625,
Okay, x is equals to 4,273.50.
50. On point. Thank you for that. So that is what we have, guys. Our x is 4,273.5. So we're done with the first calculation. So if they want to pay over or pay the loan off over 5 years, they will need to pay that amount, 4,000 something. So let's go ahead, guys, and have a look at question 2 or 1.2 rather. So we're still on question 5. Let me add a few pages here. And we go and cook this one. And remember, guys, you can always ask me questions. And this question that we are going to do now is extremely important, especially for, those problems that they will bring when they want to take away your marks. Anyway, this is question 5. And can we please have someone who's going to read for us 1.2? Any volunteer?
The client,
The client has
Okay, you guys choose each other. Go ahead.
the client has financial difficulties and only makes 19 payments. Calculates the balance of the loan at the end of the 19th month.
Okay, so what they are, maybe we need to figure out first, what are we looking for? As always, that is the question you should ask yourself. When you are looking at a question, what are we looking for? Anyone, guys, wants to give this a shot? What is it which we are looking for here?
We're looking for the outstanding balance from the original loan.
And okay, so you're saying we're looking for the outstanding balance of the loan at month 19. Okay, I see. And how do we find that? Do you guys remember? Anyone? So there's 2 ways, guys. Okay. Let me give you this one. So what happens is whenever we are looking for, what we are looking for is the outstanding. Sorry, why am I writing outing now? We are looking for the outstanding balance. So we guys shouldn't be doing any outings. We'll do outings after getting those distinctions. That is what we're looking for, the outstanding balance. Essentially, in simple terms, that is the money we still owe after that, 19 payments we still owe. So there's two ways, guys. Two ways. So you choose the one which you like. So remember that in order for us to finish this loan on time, we needed to pay how much? We needed to pay this amount here per month. We needed to pay that. But now we are at month number 19 and we are having difficulties. So remember that what happens is the two ways. Maybe let me start here. So the first way, what we will do is we'll use the present value formula. That is the first way. And I need us guys to think carefully. You should be able to make sense of these things. So with the present value formula, what we know is that we needed 5 years to make this loan to be done. And remember, our compounding period was 12. So which means the number of payments that we need to make. So total number of payments will be what, guys?
60.
Yep, so the total number of payments will simply be 5 times 12. Because remember, we're paying for 5 years and every month. So that means this would be 60. But if you look carefully, we have a problem. The problem starts. If you look carefully here, after the 19th payment. So after payment 19. So because we know how much we need to pay per month, if we didn't default, we can figure out that, okay, so we have how many payments that are left from 60. So if you look carefully,
41.
guys, yep, we can figure out that we have 41. No, sorry, we have, let me put it this way. We have 60 minus 19, which is equal to 41 payments left. So we can calculate using our present value formula. If we were paying the same amount, the X which we found, how much is left? Because we know we have paid up to the 19th payment, but we are missing or we are left with 41 payments. So we can, wherever we see N, go and put the 41, and that will tell us how much we owe. Does that make sense, guys? This is genius. It's very important that you listen. So now I'm going to go to my formula, which we know PV equals X. Show you two ways. 1 minus 1 plus I, all to the power of negative N. And this will be divided by I.
Eh,
Yes.
mo go PV, are re be OB? Are we not putting OB?
OV for outstanding balance.
Yes.
Okay, we can do so. So the
Or it's
reason
not
why
a must.
no, so the reason why I'm putting PV is because you would know what the PV means here.
Yes, we
So
do.
yeah, so
Mm.
you need to know what am I calculating. So I'm using this formula fundamentally to calculate the outstanding balance. You'll see how we'll conclude our answer. Okay.
Okay.
So we know that our X, which is our monthly installments, we said it's 4,000 what? 273, comma 5. That is what we have as our monthly installments. And all the other things, they remain the same. So that I is 1% and so on. But here, what we are going to do where we see N, we are going to replace it with 41. That we have 41 payments left there. So what we are going to do is we are going to say PV equals this 4,273,5 into 1 minus 1 plus 1% divided by 12 into minus 41. And let's quickly make some space. This calculation, guys, is extremely important. They will ask you what is the outstanding balance. You need to be able to do it as we do it. There's two ways. So can I have anyone who has a calculator to quickly punch this for us? What is the PV? What is the answer?
172
100 and
72,000
mhm,
183.
183.
Wait, no, so you put an extra one.
An extra one. Okay. So you said 172,
And then 183.
183, like this.
Yes, comma 55, comma
Comma
56.
56. Let's make it to be one decimal place and make it 7. So when you punch these on your calculator, this is what you get. Okay, not a problem. So that becomes, guys, our outstanding balance. So our balance is equal to that 2,172,183,7. Do you guys understand the thinking behind here? The trick with calculating the outstanding balance was looking at how many payments did we make? How many payments were we supposed to make in total? And then now we look at the payments, the payment period that we didn't cover. So we only did 19 months here, but we were supposed originally to do 60 or 60 payments. So now what we do is we say 60 minus the payments we have done. So we are left with 41 payments. That is why on the end, what we will use is the 41 there. So that, guys, that's the trick here. If you get that right, you are ready to go to the moon. Any questions, guys, on outstanding balance before I show you the second method? So here I will just put up a note and say number of payments left. So make sure that you guys don't forget this. But we said there's two ways. That is what we said. So this was the present value formula using it. There's another way, guys. The second way is for us to use the present value formula and the compounding on the compound value interest formula. What did I just do now? Undo. Let's add another page here, guys. Another one. Okay. So there's another way. Remember, I said there's two ways. So this one here, we'll call it method 1. First, we said there's two ways, so this will be method 1. So let's go to the second one of finding the same problem. We'll call it method 2. So I'll copy that, paste it here. And remember, we're still looking at that question. So this one, we'll call it method 2. And with method 2, what do we use? We will use the PV value or the PV present value formula. Use the present value on and the compound interest formula. Compound, let me say compound formula. These are the two that we will use for method 2. And the formula goes as follows, guys. The formula is our outstanding balance for the amount which we owe. Outstanding balance will always be given by our A. You should know when we speak of the compound formula, what is A? Minus PV. This is another formula. So this side, we use the other formula. Let me say outstanding balance. We used the compounding or the PV formula only. Outstanding balance, this side was as described with the PV that is here. Maybe let me make that to be pink. I hope you guys understand. So I'm spending time here because I've seen many of you do get this question not correct. So let's quickly go ahead and have a look at what is happening here. So the nice part about using this formula, guys, is that you do not need to worry about what is happening. So if you remember your A, so this outstanding balance, we'll call it OB. So it will be, if you remember, you have P, which is the present value, whatever which you are owing, and you'll have 1 plus I all to the power of N, and then minus the PV is X into 1 minus 1 plus I all to the power of negative N, and this is divided by I. So now, guys, what you need to note here is that for N, this is very important. The N which we put here is the amount of payments we have made. So N equals amount or the number of payments made. Number of payments made. This, guys, here is very important. While on the other side, our N was the number of payments left. I hope you can see that. This note here, it was the number of payments left. Meaning we did 19, but we were supposed to do 60. So 60 minus 19, 41. If you want to use this formula only, you must put in 41. If you want to use method 2, N will be the number of payments that have been made. So in our case, guys, do you agree that N is 19? Isn't it? Where are my thumbs ups? And P, which is the amount which we owe, is 250,000. So we as good as done. I is 1%, still stands. M, the compounding period is 12, and so on. We have all what we need, and we have also our X. Our X is 4,273,5. So now let's go ahead, guys, and find our outstanding balance. So we'll have 250. I'll need you guys to use your calculator into 1 plus. We have 1% interest. Remember, we should divide by 12. And the N here, we said it is the number of payments you've made, which is 19, minus X. Sorry, our X is 4,273,5 into you guys should be using your calculators. 1 into 1 plus 1% divided by 12, all to the power of minus 19. We create some space. Minus 19 like that, divided by 1% divided by 12. So what do we get as the answer, guys? What is our outstanding balance?
I'm sorry, why is that 4,273 a negative?
It is because the formula I gave you has a minus in between them. Do you see?
Oh, okay. The answer is negative 79,845,46.
You are saying the answer is negative?
79,845,46.
Oh, yes, you are right. There's something I made a mistake here, guys. My apologies. Let me quickly fix that. So method 2, we shouldn't get a negative answer. I just remembered now. Method 2 doesn't use the present value, guys. It uses the future value. So I'm able to see because we are getting a negative answer. So let's quickly fix that. So here you should go on your paper and make sure that you guys have future value for method 2. The first one uses present value, method 2 uses future value. So I need to rearrange this bucket here. My apologies. To the n minus 1 here. Yep. Let's give it a shot now, guys. Future value. So I need to have 1 plus 1% divided by 12. And this will all be to the power of n, which is 19, then minus 1. Yep. Let's fix that, guys. Please make a note. This is easy to mix up. So what we do is we use the future value. For method 2, what do you get? We should get the same answer as we did. What is the answer, guys? Anyone who has it? What is the answer? It should start with 172. You can give me the other numbers.
179,
179,
8,
79,
8.
8. So let's see, 170. Let me see our installment. 423, comma that, comma 5. And the other one we got 183. Why are these two different, guys? Let me see. Not too different, but I was not expecting them to be this different. So let's see if we didn't make any mistake. So future value annuity 4,273.5 into 1 minus open bracket. Sorry, 1 minus open bracket. We have 1 plus fraction of 1%. This is all divided by 12. Sorry, why is this thing not doing proper things? And all of this to the power of minus 1/4. And then close the bracket. And this is divided by 1% divided by 12. Close that one. So we're getting 172, 13.55. Why did you guys get a 7? Where did you get a 0.7?
You have rounded off to the 1 decimal place.
They rounded what off?
No.
Okay, let's make it 0.6. It's okay. So we can just make it 0.6 if you want to just maintain 1 decimal place, guys. That is not too much of a difference. I'm not worried. Now let's go to the next one. So for this one, we get that. For the next one, what we are saying is let's go 250,000 into 1 plus 1% divided by 12 and close the bracket. We put up how many payments we have made. We made 19 payments minus the future value annuity, which is 4,273 point. We use 0.5 and then open the bracket again. We'll have 1 plus the interest rate, which is 1%, divided by 12, close that bracket, all to the power of 19. Then minus 1 and close that bracket. So we need to divide by 1% divided by 12. Okay, 190. So it gives us what you guys said. So what happens is the problem which we face, which I have seen with these problems, is rounding off errors, if I can call it that, because we seem to have done everything correct and the answers are supposed to be very close. So if you look at what we have 172 and then 179.8. So this is okay. So there's these two ways, guys, to find your answers. If you look at them, the answers are, they have a 3 lines difference. So both ways are going to get you all the marks. And remember, when they mark, they have a tolerance. So it doesn't mean that if one of your classmates gets 179, another one gets 180, one is going to be wrong. So you could find your answer this way or this way. You will get the answer correct. Do you guys understand both methods? So this difference of these last 3 numbers, you shouldn't worry. It is a rounding error. And for that, no need to worry. So you will get the mark. Any questions, guys, before we move away from outstanding balance? If you understand, please give me a thumbs up, because you can't be in between. That is one thing I'm going to tell you. There's no in between here. Either you hear me or you don't. And that is why I'm asking you to please ask. Because in your exam, a problem is waiting for you. They will say, how much are we owing? Outstanding balance. And you need to be able to calculate that. For method 2, this is the heck, this formula. Outstanding balance is A minus FV. Very important, guys. So let's go to the next problem. Which is going to be our last one for the day. Today we're going to have a shorter session. This is going to be Q6. So if you look carefully, guys, they tell us that Lord Well, very nice name, Lord Well. Lord Well buys new printers for 350,000. How much will the printer be worth in 5 years' time if its value depreciates at 8% per annum on a reducing balance? So let's go ahead, guys, and look at 1.1. So I see that a key term that they mentioned there is the term reducing balance. There's the term reducing balance, and another one is depreciation. So I want to quickly remind you of something, guys, when it comes to depreciation. We covered this weeks ago, but I'll just remind you the interest of this lesson. So whenever we're dealing with depreciation, we are dealing with two types of depreciation. You have one, which is a reducing balance, and you have another depreciation, which is a straight line depreciation. And these ones, or these two, have slightly different formulas. So for the reducing balance one, you'll have the present value. So I'll use A still. You'll have the present value and you'll have 1 minus I into N, while the straight line one will be A into P, 1 minus I times N. It's very important that you guys remember these. Okay. So now that we remember this, we can see that they are saying reducing balance. So clearly we need to use the formula of depreciation just below it. So our present value of the printers, if you look carefully, is 350,000. So we have 350,000, that's the value of the printers. And the I, which is the depreciation rate, is 8% per annum. And they are trying to assess this printer after N is 5, after 5 years. So we can now go ahead and figure out what is the value of the printers after 5 years. So I need one of you guys to use your calculator with the reducing balance method, 8%, all to the power of 5. What is the answer, guys? Equal. What do we get? So the printer is now 350,000. It is depreciating at 8%. How much will the printer be worth after 5 years? After 5 years. Oh, I need to put in more zeros
So
there.
you wrote 3,500.
Yep, and I want you to give me the answer. There you go. What is the answer?
$230,678.53.
Okay, awesome. So we can now just make a comment and say, okay, the value of the printer will now be that. So look at how it has lost value. Of the printer will be the 230 678,53 after 5 years. Okay, very important question, guys. Then let's go to 1.2. So when you look at 1.2, they say after 5 years, the printer needs to be replaced. They like these problems, guys. During this time, inflation remains constant at 6% per annum. Determine the cost of a new printer after 5 years. So what happens, guys, here? What does inflation do to a product?
It increases its price.
Yep. So we should remember that inflation, now I'm writing inflection, which is looking even very wrong. So what you guys should remember is that inflation increases prices. And this is the interesting part. When you use something, it loses the value, but something that is not used, the inflation for the same product 5 years later would have made it to be more expensive. So it means when we are now looking at the same printer after that 5 years, the ones that are still being manufactured, they will not be at 350 now. They will be inflated. So we need to use the compound formula. That is what we need to do, where I will be 6%, and that is the inflation rate. This is very important, guys. And if you remember, A is P into 1 plus I, all to the power of N. So we can now calculate how much is a printer going to cost after 5 years with that inflation. So we have 1 plus 6%, all to the power of 5. What is it, guys?
$468,378.95.
460.
No, sir,
Oh,
it's 468,378.95.
yep. 95 on point. Thanks for that. So we can now see clearly that the new printer will cost that amount after 5 years. So comment, a new printer will cost that amount, will cost this 468,700 and nope, 468,378.95 rands 5 years later. 5 years later. Do you guys understand what is happening here? Is maths not beautiful? If you think it is not, please listen to me more. You will appreciate it. So this is the amount that we need to pay for the printer after, those amount of years. Now let's go to 1.3. And then they say, I'll copy it to the next page. We know how much a printer will cost, and I know very well this is a businessman. So he wants to make a plan to buy the new one. So they say, guys, he plans to sell his printer at its book value. So meaning the printer is currently using, it would have depreciated. Calculate how much money he will need to put in to his sink fund to buy a new printer. So guys, remember that this man has an old printer. In 5 years' time, the old printer, when he sells it, we are looking at this question. The old printer, which he will sell. So the old printer, if you remember, will be worth, you can sell it at 230,000 and a few cents. Well, 230,000 and a few pennies. Yeah. So this is what he's gonna get for his old printer when he sells it. So now we need to figure out how much money does he need in order for him at the end of the 5 years to be able to buy a new printer. So this one here, it is the amount he will get when he sells the old printer. Amount, Lord Well, nice name. It is the amount Lord Well will get when he sells his printer after 5 years. That is the amount that he will get. And the question is, calculate how much money he will need to put in the sinking fund. However, he knows that a new printer will cost him what we just calculated because of inflation. So inflation is not good, guys, isn't it? It is bad. So we need to make inflation to disappear. Any ideas? So the new printer will cost him this amount. So now the question is, before he gets to year number 5, how much does he need to have on his pocket such that at the end of year 5, he's able to buy a brand new printer? Guys, very simple question. Imagine. What do we do? Anyone? This one here, it is the amount, or it is the cost of a new printer 5 years later. Anyone, guys? How do we get
You
the
have to
answer?
subtract the new printer price from the old printer, and then the amount that you're gonna use it as your future value to see how much money you need to put in monthly as your sinking fund.
Not the amount we need to put in monthly. Do you agree? But it's going to be the total amount that we need to add on top of what we are going to get out of the printer to be able to afford it. Do you agree? It is the amount we need. I'm not sure if that makes sense. Do you understand?
Oh, yes, sir.
Yep. So the money needed, which Lord Well needs, will simply be the amount of the cost of a new printer now, which is 468,378.95. I need you guys to subtract that with the old printer, 230,678.53. So how much does Lord Well need at the end of the 5 years for him to add on top of what he's going to get from the old printer to be able to afford this new printer? How much?
He needs 237,700,42.
So you say he needs
37,700,42.
700,42. Yep.
Yes.
Awesome. Thanks for that. So this is the amount that Lord Well, our Lord, needs to be able to get himself a new printer after these number of years. So that is the amount that he needs. Any question, guys? So remember, sinking fund, if you remember, when we are creating a sinking fund, essentially, we are trying to figure out if we put money on the side, how much are we going to have come the time that we need. So this is will be our sinking fund. So this is the amount that we need to work to make sure that we have at the end of those years, and then we'll be good to go. So let's go to 1.4, guys, and wrap up. So 1.4, they want us to calculate the monthly payments to the sinking fund. So one thing I need you to remember, if you remember, sinking fund, if you remember the future value formula, the future value lesson, we put it under there. Sinking fund is a future value annuity. That is very important, guys. When you see sinking fund, it means they are asking us, how can we invest that total amount for the future? So Mr. Lordwell knows that he's going to need 237,000 5 years later. So he's going to set up a sinking fund where he will just do his savings, monthly savings. And we remember, guys, that our future value is given by x into our 1 plus I all to the power of n minus 1 divided by I. And we have all what we need. If you look carefully, we are given that I is 9.5%. And remember that we are working with an n value of 5 years and a compounding period, if you look carefully, of monthly. And our future value for our problem is equal to our sinking fund, which is 237,700,42. So we can now, guys, go ahead and substitute this and see what we obtain as x. 37,742 equals x. We do not have, open bracket. We have 1 plus. I need some of you to be punching your calculators already. The interest rate is 9.5. Then this is divided by 12, all to the power of 12 times 5, because we are going to invest for 5 years monthly, so that come the end of that term, we have the amount we need. So this will be 9.5% divided by 12. So let's go ahead, guys. Please punch all of this for me on your calculator, the green part, and give it to me. What is it?
$76.42.
Okay, so what we have is that 237,700,42 x is, you said 76.42. Is that what you said?
Yes, sir.
Awesome. So because we're looking for x, we must divide both sides by 76.42 divide by 76.42. So when we divide by 76.42, how much do we get, guys, as x? What is our x? So obviously this and that will cancel. What is our x value?
3,110.45.
So 3,110.45, is it?
Yes, sir, but then it's 3110.45.
Not 110. 3,010.
No,
Like
sir, it's 3,110.
it is giving Zuma effect. I wrote 300,000. Yo. Yeah, no, this is bad. So 310, comma.
No, sir, the answer is 3110.45.
Not 3,010, 310. Yo,
No.
yo. Is looking bad. Yo. Yeah, you guys should watch. You know those politicians, and they said, read this number and it's a billion. And you see them laughing. They know the first two numbers and they start laughing. Anyway, you said it is 310, comma. Please give me the decimal. But this is odd. No, no, no. Yep, you can go ahead. What is the answer, guys? Are you saying 310 or 3,110?
It's 3110.45.
3,110.45. So this is 3,110. Okay, awesome. So this is the amount, guys, they need to put in monthly so that come year number 5, they'll be able to afford that difference, which is their sinking fund, for them to be able to pay off to supplement the money they will get from selling their old printer to get the new one. Do you guys understand? This deserves a smile. This was a funny moment. It's for me. I'm hearing 300,000 and then now it's 3,000, 30,000. Anyway, do you guys understand? If you do, please give me a thumbs up. And if you don't, you can ask, where are you lost? So it means you guys should be able to go and ace those sinking fund problems, isn't it? Yeah. When they say sinking fund, you should know they are looking for the amount that I will need to supplement to get whatever which I need, which is depreciated. So sinking funds will be associated with depreciation, guys. So please make sure that you do understand that. There's no question, guys. Let's call it a day. I think we are done with financial mathematics. Next, we are going to be working on stats headed to probability. Thank you, guys. Cheers and have a great day. I see a question from Ayabonga. You can ask.
So I have a question. It
Yes.
says Mandy takes out a 10-year loan of 80,000. She repays the loan by means of equal monthly payments starting 4 months after the granting of the loan. The interest rate is 12% per annum compounded monthly. Calculate the monthly payments. So
Okay. Yep.
okay.
So what issue did you face there?
Okay, firstly, I first multiplied the 10 times 12. And do I have to subtract the 4 months, or do I have to subtract 3 months, since there has to be a 1 month gap after the payment?
No, you make it to be 4 months.
Oh, okay. Thank you, sir.
Yep. You remember the problem we did of the timeline?
Yes.
Yep. So you go and work that out, and then you'll work out the principal amount, the P or the present value amount. This will be at the end of the month number 4 going forward. And for this, if you remember, you will need to use your P into 1 plus I all to the power of N. You remember that working which we had?
Yes.
And your period will figure out maybe until the end. If this is 60 months, It means here in between you have about 56 or so. Yep. And then you just calculate now your monthly installments based on this 56 instead of 60. Does it make sense?
Yes.
Yep. Maybe post that question in the group and all the people will attempt it as homework.
Okay, so I have a second one.
Yep.
A loan is repaid starting in 5 years' time by means of 12 quarterly payments of 7,000. What is the amount of the loan if the interest is 24% per annum, compounded quarterly?
Okay. So what problems are you facing there?
The starting in 5 years' time.
So if the loan is starting in 5 years' time, maybe read the question for me. Let me figure out what is given.
A loan is repaid starting in 5 years' time
Yeah.
by means of 12 quarterly payments of 7,000. What is the amount of the loan if the interest is 24% per annum, compounded quarterly?
So they don't say the loan is paid in 5 years. They say we start paying in 5 years.
Yes.
And they don't tell you how many payments we make.
By means of 12 quarterly payments of 7,000.
12 quarterly payments of 7,000. And we only do it for 1 year. Okay. No, that is easy because they didn't specify the years. So here's what you need to do. The first thing that you can do is, because they are saying starting in, think of it, you'll need to work in reverse. In 5 years' time, we don't know what the amount will be, which we would have been owing, but we can calculate the amount that we are trying to pay off by using the 7,000. Do you understand? 7,000 compounded quarterly using the future value, no, the present value formula. You will get the amount which you were trying to pay off. Does it make sense?
Yes.
And then after getting the amount which you are trying to pay off, and then you now know that that is your A in your formula when you reverse this thing, isn't it?
Yes.
And now what you are looking for is your P. And guess what? You have the I, you have the M, which is 4, and you have the N, which is 5. So you can calculate that back. Does it make sense?
Oh, yes. Thank you.
Yep, awesome. Please send that also in the group, and the other guys will try it out too. So guys, I'm out of time for today. Give those questions a shot and maybe we'll attend to them on our next lesson. For now, cheers, take care and enjoy. Please make sure you do your homework. So please, Ayabonga, send those questions in the group and you can write their homework and everyone should engage with them. Thank you for the question. Cheers.